YouTube. Okay, now this says it's Module 13, which is correct, and it also will say later other things. Let's just see if some of the other slides are more white space. That has a little more white space. We're not in Section 13.5 yet. We're so close, but not quite there. I think that probably has the most white space, so that's where we'll go from. There is a major announcement that I want to make, at least a few of them. Let's start with where we are as a class. This class probably has done one of the better jobs, especially among my big classes, about getting research papers in. But that's still, I think, less than half. Which means, of course, welcome back. How you doing? Sorry. Okay, Rebecca's here.
I found this.
Oh, thank you. Let me also say this. I apologize about the temperature of the room. If y'all feel a little cool, even I feel a little cool, and usually I'm hot in a cool room. So when I first came in this morning, I checked the box. It's dead. There is absolutely nothing showing there. I'm not talking about you, Drew. Drew's here. And I can't control anything from the box, but usually it shows the set temperature and the room temperature and maybe a couple of other words on the screen. Nothing's on the screen now. Okay, nothing. So I tried pressing all the buttons. Nothing happened. I got up in a desk and felt there's absolutely no air coming out of the ventilation here. So I went down to call maintenance to let them know the system's not working. I said, no, this room's not incredibly cold, but, you know, we can live in it. But I said some of the other rooms on the system may be very, very cold. I don't know. And, of course, the number I called was for this campus. It rang and rang and rang, and finally someone picked up on the other campus, and here's Q. So I started explaining to her, and she said, well, the normal procedure is for you to do a maintenance request. I said, well, I've got class starting in just a few minutes. I don't even have my computer lit off here on my desktop, and I'm trying to set up for class now, so I don't have time to do a maintenance request until after my next class is over with, which is after 11:15. People may be freezing by then, so, until we get a phone call from a classroom that is really, really cold, we can't do anything. I said, my phone call won't work for you? And she said, well, I'll send an email to Chad, and if he can monitor the system from where he is, he might be able to do something. He's the maintenance coordinator, I guess, for both campuses, but he used to be out here. I said, well, I can't do anything from my box. It's a new system, so I think they monitor from somewhere else. Well, we'll see. Maybe he'll email you back. I said, well, I won't be able to check emails until after 11:15 today. So she said, we'll see what we can do. So I don't know what that means. Okay. But anyway, that aside, I was saying that just looking at it, less than half of you have turned in a research paper, and we have, this is the last week in November to get that last little bonus point. Next week is the last week of class, typically, and so you don't have a lot of time, one weekend left to get your research paper done if you work on the weekend. Well, this was the very best class I've ever had about getting that first quiz in on time, or close to on time. Everybody got it in, I've returned it to you. Same thing with first test. Best class ever to get the first class taken real close to the due date, and I got them returned to you. But then quiz 2, I'm still missing 1, 2, 3 people from that. But of course, those 3 people haven't been in class for a very long time, so I don't know if they're coming back or not. Test 2, now all your grades are out on Blackboard, by the way. If you haven't picked up on that, they should be on Blackboard now. I tried to get them all in over the break, so they should be there. Let me know if you don't see them. If you don't see a test score there and you know you took it, that's because I wasn't sure if you're coming back to finish the test or not. Some people indicated they were. Some people gave no indication, but by leaving things blank, I assumed you were coming back. So please let me know if you are going to accept the score that you've got. You can come see that score and decide whether you're going to finish working on the test. So some of these blanks here are because people haven't taken the test, others because I wasn't sure if you were finished or not. Quiz 3, 1, 2, 3, 4 people haven't done that. And again, I think there are people who have not been here consistently, though a few have been back. And let's see, is this Taylor? Okay. All right. Get Taylor here. There you are. Okay. And what was that? Quiz 3. So please get those past quizzes in. If you didn't get one, please get those. Okay? Test 3, then at least those 3 people, and a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. And again, some of you may have done it, started the test, but I didn't know if you finished or not because you left quite a few blank. And then quiz 4, I've gotten not quite half of them in, but they're still coming in. So you need to get those in soon because we're, good. And here's, I think, the research paper. Okay. Good deal. All right, and the quiz. Okay, let me get rid of that. So that's a little bit on that. Now, here's kind of the bad news. We had professional meetings, that may have been bad or not, Monday and Tuesday. And in Monday's meeting, one of the instructors from the Birmingham campus who had volunteered to do the final exam was only that you need to review the final video. You need to look. I said, well, look, hasn't Miss Martin already given it to her mini-term 1 class? She said, well, yeah. I said, well, what does she think of it? Yeah, I won't really know until I've given it once. You know, I can look at it, but I'm sure you did a good job putting it together. And so anyway, we got to talking, and she said, blah, blah, something about 8.2. I said, now, wait a minute. In our meetings, first meeting we had on the new text, we went over what we're going to cover. We were told 8.2. But then when the syllabus came out, they didn't include 8.2. So I called the guy who had been at the state meetings about what's going to be covered in Math 100 now. And he said, no, we took that out because 8.2 is covered in 112. So we took it out of this time. Oh, okay, so I adjusted my thing just to finish through 14. Well, she said, no, 8.2 is in there. I said, well, that's not what Wayman said. So he got into the thing and said, oh, yeah, I remember our conversation. At that time, I thought it was out, but then someone said thus and so to me, so I thought, well, it should be back in there. I said, well, look, I did my syllabus based on what you told me. Yeah, I understand that. So I can't include 8.2 because the syllabus didn't include 8.2. And they said, well, we'll just have to let those be bonus problems for your class. And for several other instructors, when they heard our conversation, they said, no, we were told not 8.2. So about half the classes are covering 8.2, about half are not. So here's what I want to do, or propose to you, unless you see if this is okay with you. Our exam is scheduled for Monday, 8 to 9:50, an hour and 50 minutes on Monday. Not this Monday or next Monday, the following Monday, finals week. So what I would propose to you, because I don't think we're going to finish everything, to include 8.2, and I want you to get as many bonus points as you can, what would you say to having class, a review session, that Monday that we normally would be having the exam, and then any time after the review session is over with, you can come in and take your test. You can do it later Monday, you can do it Tuesday, you can do it Wednesday, regular class time, especially if you don't have a 9, in fact, I don't think there is, yeah. In fact, I don't know what I guess I said 8 to 9:50, 8:30 to whatever, 10:20 or whatever, because we've gone to the new time, so I don't know what the new times are, but it's going to be something like that. So if you want to do that, I'll be willing to do that for you, and that way you can ask me on anything, not just the 8.2 stuff, but anything. And now, if somebody doesn't want to do that and wants to follow the original exam schedule, then I'll get someone to practice the test for you on that Monday morning. But for the rest of you, if you want to have a review session, I'm happy to do that. And then anytime later in the week, whether it's Wednesday at 8:30 or whatever, later on Monday, anytime during the week. But are any of you graduating this term? No. Okay. Then anytime up till, now graduation is sometime Friday. I won't be able to do it on Friday. So anytime Monday through Thursday, I'll be able to later after our review session on Monday up until anytime on Thursday, I'll be able to let you do the test. I'll go over my hours that I'm here and where I'm going to be. So you can come in when another class is taking their test, whatever. Or come by my office and we'll find you a classroom. So how does that sound? And here's Saya. And also Sierra. Any others that start with a soft C sound? Oh, Pablo, you don't start with a soft C sound. Okay. Any one else come in since I hold it? All right, sorry that was too long, but I just wanted to say that. For those who just came in, go back and listen to the first part of this thing on YouTube when it gets out there, which will be sometime later today, probably. All right, any questions before we get going? Okay, we're in the very last part of section 13.4, that last focus on using a radical equation to solve an application. And I wish they had this on the PowerPoint because I don't want to write this whole application. Here's the application. How far above the water will a submarine periscope have to be for the lookout to locate a ship 5 miles away? Oh boy. Okay. And remind me? Huh? Field. Okay. Latasha, right? Okay. Anyone else coming since I called on? Okay. I'm going to have to do some drawing here. If you got your book, there's a very nice drawing in the book. Okay? But this is, here's the picture. How far above the water will a submarine periscope have to be? So here, and I'm going to try to do my thing sort of like theirs. Now that's a gross exaggeration of the curvature of the Earth. But here's the submarine with his periscope up here, okay? And here is and the question is how far above the water. So here's what we're looking for. Do you want to give that a name of a variable? You get to choose your name. I don't care. Anybody?
X.
Second?
X.
X. Okay. Wow. What a creative name. Okay. All right. So there we have X. How far above the water would a submarine periscope have to be for the lookout to locate a ship 5 miles away? Now they show the ship over here on the water. That's a pretty ugly ship, isn't it? Okay. Anyway, there's the ship. Okay. 5 miles. 5 miles away. So this distance here, line of sight distance here, is 5 miles. Now the way I've drawn it, obviously he can't see the ship. Well, maybe if I drew it to the upper part of the ship, he might be able. Whatever. Okay. But that's 5 miles away. Okay. The equation for the distance in miles that the lookout can see, here's the equation. They are giving it to you. Thank you very much. We don't have to derive it. Is equal to the square root of 1.5 h. X is no longer any good. This is h now. Okay? That's the height of the periscope. Square root of 1.5 h, where h is the height in feet above the surface of the water. Sorry, I should have read the problem first without having you give me one. Okay. Round to the nearest hundredth. Okay. Now, this equation, strangely enough, is already set up for miles for the distance and h in feet, which is really bizarre. Most equations aren't set up for different units, but this one is, so all we have to do, the h is what we're looking for, 5 miles is the distance. How do we solve that equation? Not too bad, is it? The distance is 5 miles. It's not hard. Don't think there's something trick here. It's a pretty straightforward problem. There's your equation. There's the distance. There's your unknown h. What's your name, please? Huh? Second? Hey, oh, Zayla. I know, I can't talk. That's the problem. I can't hear and I can't talk. It's just a bad combination. Okay, sorry about that. All right, how would we go from here? You plug it in, just like Glade, right? Okay. You put 5 miles here is equal to the square root of 1.5 h. Now that h is under the radical, okay? I've been trying to show that. Usually it's a good idea to put a little hook down there to show everything inside the hook is in the radical. How would we solve that? Again, pretty straightforward. Say again? Yeah, square both sides. You don't just square one side, square both sides. And what does that give you? Square this and square that. What does the left-hand side become? Pretty easy. A little outer. I heard 5 squared, 25. Very good. Right-hand side becomes 1.5h. The square undoes the square root. Okay? Now it's pretty simple. What do we do from there? Okay, so we'll isolate the h, get a naked h there, okay? Divide both sides by 1.5. I can't write. Goodness gracious, this must be a Monday. Okay. Divide both sides by 1.5. Okay, this goes away. What does h become? Pull out the little black boxes.
16.66.
Second?
16.66.
16.6? Yeah, is that what you said? Okay. 16, yeah. Let's just say, because we only got 2 digits, only one. Yeah, 16.7. So I'm going to even round that to 17 feet. Okay? I've been on a submarine before, and when I was in the Navy, and I don't think periscopes go up to 17 feet. So, in other words, he's not going to detect a ship 5 miles away. But that's not part of the problem here. They say 16.67 feet. Here's my issue with that. That's only 1 significant digit there. This has 2 significant digits. There's no way in the world we can get 4 significant digits out of that. Okay? Remind me? Okay. K was Simpson, right? Okay. Got so many names that are so similar. I want to make sure I put you in the right one. Okay. So that's why I say about 17 feet. Okay? And guess what? Between 16.67 and 17, you're talking about 4 inches there. So 17. It's not going to reach that high. So it's not going to see it. But that wasn't part of your problem. Okay? It just said the periscope must be 16, almost 17 feet above the water. Nah, not going to happen. Okay, there's a check your understanding there, which is a very practical problem. You use it in physics a lot, so I'll let you work on that one. It's a pretty straightforward problem. Has an irrational number in it, but that's okay too. But most square roots are irrational, so that's not surprising either. And then there's also 4 practice problems. Please do those. Any questions on 13.4? That was the last part of 13.4B, or C, whatever the last section was. Okay, 4B. Okay, let's move on to 13.5, which is rational expressions and radical expressions. Okay? Now, haven't we been doing this? Okay? The Is that really what it said? No, rational exponent and radical expressions, which I think we've been doing all along. And the objective here in 13.5A is simplify expressions with radical exponents. Rational exponents. Boy, I can't read today. Now, in this section, the definition of an exponent is extended beyond integers. Up until now, we've been talking about exponent of a 2 or even a -3. And we can handle those. Those are all integers. Now we're going to extend that definition of exponent to be rational exponents. Okay? What do we mean by rational? It has nothing to do with gender, by the way. So what do we mean by rational? Ratio, which is basically ratio of 2 integers would be a fraction. So your exponents can now be either fractional forms, which is mostly what we're going to use. They could be decimal numbers. We don't usually use that. We usually use the fraction form. So the integers can be any rational number and be used as an exponent. The definition is expressed in such a way that the rules for exponents hold true. All those rules we've been using all along, they still hold true when you have rational exponents. So let's consider this expression. A to the 1 over n, where n is an integer, not 0, by the way. That would make no sense whatsoever. Okay. Thank you. Okay. Raise that to the nth power. Now, if our rules for exponents hold, when you're raising a power to a power, what do you do with those powers? Say again?
Like raising power to a power you're going to
multiply the powers. And what's 1 over n times n?
N would be 1, let's see, 1n over n squared.
No, this is the numerator. 1 over n times n. Okay, it'd be n over n. And what's n over n as long as n's not 0? 1. So that gives you an exponent of 1. So you just have a. A to the first power is a. Okay? And that's true for any a greater than 0. Consider this expression for any a greater than 0 and n a positive integer. Positive integer. Okay? I didn't even say it had to be. I just said integer. Now simplify, assuming that these rules still work, and I just did, and that gives you a. Okay? Now, because they don't need a comma here, they maybe one there, but not here. Because this is true, a to the 1 over n raised to the nth power is a. The number a to the 1 over n is a number whose nth power is a. Okay, right. Okay, that's what it means. Okay, I'm not sure why they're throwing all these unnecessary words in here, but anyway, it's all right. So here's the definition of a to the 1 over n. If n is a positive integer now, positive integer, then a to the 1 over n is the number whose nth power is a. That's what we just said at the bottom there. So let's do a few of those. What would be 9 to the 1/2? In other words, if you raise some number to the second power, you get 9. Third power. 3, I mean, just 3. Okay? Yes, that's 3 because 3 squared is 9. How about this one? 64 to the 1/3 power. What number, if you raise it to the third power, gives you 64? 4. Perfect. Okay? Because 4 cubed is 64. Negative 32. Ooh, can we do that to the 1/5 power? The answer would be, if you had a number, raise it to the 5th power, you want to get negative 32. What number would that be? Say again? I hear the gears grinding there, so I know the thinking's going on. What number would that be? Say again? -2, perfect. Exactly, because -2 raised to the 5th power is -32. Okay? All right. So that's what the definition of a to the 1 over n is. Now, I hope they're going to give you something a little simpler than that. And maybe or maybe not. So, taking this, okay. So if a is a negative number, which we saw in that last one, and n is an even integer, then a to the 1 over n is not a real number. Because there is no way you can raise this to an even n and get a negative number on it. You just can't do it. So therefore, that would not give you a real number. For a -9 to the 1/2, can you give me a number that, okay, thank you. Okay, thank you. Okay. Because there is no number that you can square and get a -9, is there? No positive number will give you a negative number when you square it, and no negative number when you square it will give you a negative number. Square a negative, you get a positive. So this is not a real number. Now, use it, but when that was odd, that would be perfectly fine. Okay? The denominator being odd. So using the definition of a to the 1 over n and the rule for exponents, it's possible to define any exponential expression if it contains a rational exponent, fractional form. So here's the one when it's a to the m over n, not just 1 over n, m over n. Okay? If m and n are both positive integers, not 0, positive means not 0, it's certainly not negative, then an a to the 1 over n is a real number. In other words, a is not negative and n being even. That can't happen. Then a to the m over n is the same as a to the 1 over n times m. Raised to the mth power, which is just decomposing, you might say, the rules for multiplying exponents. Because if you multiply this, you get that. So when you got this, you can undo it like that. They're sort of making this a little more complicated, I think, than it needs to be. Okay? But we can still do it. Okay? Now, I don't need to cover anything. They don't have the answers. But let's see if they have something before we get there. Let me just see. Yes, they did. Let's back off one. Well, no, let's use that slide. Okay, before we get there to this focus, there's a focus before it. And it may be just a little bit easier. Okay? Yeah. They're going to get to what I consider a little bit easier and more reasonable way to do this. But we'll do it this way first. Okay. Here's the first one. This is top of page 20 in Module 13. Simplify this. 27 to the 2/3 power. Okay? 27 to the 2/3 power. Now, what would you do as a first step? Anybody? Make up a step. I'll tell you if it's right or wrong. What could you do? Give me a right one if you can, to simplify that. Okay. What they were just doing was taking that 27 and pulling out the fractional form 1/3 and then squaring it. Isn't that what they did in that last thing? Pull out the denominator to here and leave the numerator on the outside. And that is right. When you multiply, when you raise a power to a power, you multiply the exponents, and that's exactly what you get. Say again? I can't hear. No, you probably were right. I just can't hear. They're talking outside. Is that door open? Okay, why don't you do that? Why would you let it sit there and leave the door open? Huh? Okay, thanks. Okay. They're probably working on the system. Maybe they'll get some heat in here. For the next class, probably not for you. Okay. All right. What did you say this was? 3. Okay, this is 3. Absolutely. How did you get that? What number, when you cube it, do you get 27? 3 cubed is 27. So this part is 3. So let's change that to 3. Squared is what? This is the easy part. 9. You did it. Perfect. Okay? Let's do the next one. 16 to the negative. Is this it? No, I'm sorry. I'm looking at the wrong one. 32 to the negative 2/5. Okay? Now, you have 2 ways you can go with this one. Okay? Why would you like to do it? Either way is correct, but how would you like to do it? What would be your first step? Similar to the first step we took before. Help me, somebody. All during Thanksgiving, I was around a bunch of grandnephews and nieces, little toddlers, and they all had snotty noses, and I'm afraid I caught something, so my throat hurts. I don't want to do much talking. Y'all do the talking, please. How would you do? What would be your first step? Anybody? Second? A little louder. No, you probably said it right. I just can't hear.
She said, would you get the negative out?
Okay, I like that idea. Okay? Don't know what I want to do with it, but let's do the 32, and let's do something with it and put the negative with the 2 out here. Is that okay? Is that what you meant? What would be left as the exponent for 32? 1/5. Excellent. Okay. Now, what is 32 to the 1/5? The other way to think of that, what number, when you raise it to the 5th power, do you get 32? 2. Okay? So this will be 2 to the negative 2. And what do we mean by raising something to the negative 2 power? Didn't we do that when you have a negative exponent? Did we do that? See, I'm teaching so many different math classes, I can't remember, and none of them, this is only Math 100. Didn't we do negative exponents before? Oh, maybe not. Did we? We don't think so? Okay, if we didn't, then we're going to have to go back and do it the other way. Oh, man. Not even when we were dividing them, did we? I guess we didn't. Sorry. Okay. So let's leave the negative inside and leave the 2 on the outside. What would that make it? What number, when you raise it? Man. All right. No, they did it the way that slightly differently, but they're doing that. They did say use the definition for a negative exponent. So we did do this. I thought we did. So let's go back. We're not doing it quite the same way they did, but we're doing it close. So we're not going to put the negative here. We're going to leave the negative out there. We're going to leave the negative there. They say that you should know this, so I'm going to agree with them. When you have a negative exponent, what do you do with that? You send it to the basement, don't you? Yeah. This is the same as 1/2 squared. Isn't it? Didn't we do that? Yeah, I thought so. Y'all trying to lead me astray. And what's that? That's 1/4. Perfect. Now, they did it slightly differently. I'll show you how they did it. They took the 32 and put the negative 2/5 totally on the outside. Okay? I think that's how they did it. And then said, what is 32 as a power? And this is really fairly abstract, would be 2 to the 5th power. And multiply that by negative 2/5. And then when you multiply those together, the 5's go out, and that leaves you 2 to the negative 2, which is 1 over 2 squared, which is 1/4. I think the way we did it was a little more in keeping with what they were doing before. Okay? So they really jumped, threw a little extra in there on that. But both of these are correct. Okay? Now, that's the first focus. There is a Check Your Understanding 1, which has 2 more of those. You okay with doing those on your own? Okay. Then let's go to this focus, the one that's on the board. We'll erase all this. Anyone need it up there a little bit longer? Okay. I'll let you finish writing. Okay, everybody got it? All right. So let's erase all this stuff, and let's do this one. Okay? Now they have variables in here, not numbers. Okay? So what if you did have b to the 1/2 times b to the 2/3 times b to the negative 1/4? You've got the same base multiplying together, but with different exponents. How do you handle something like that? Say again? Keep the base, not multiply. That's if add the exponents, okay? Keep the base and add the exponents. So that would be b to the 1/2 plus 2/3 minus 1/4. Okay? I'm subtracting that last one, which is the same as adding a negative. So what do we have to do with those exponents? Find a least common denominator. What would that be? No, common denominator. Say again? 12. Excellent. Okay. Because 2 will go in the 12, 3 will go in the 12, and 4 will go in the 12. And there's no smaller number that all those 3 will go into. So this will be, how many twelfths is 2? Is 1/2. I'm sorry, how many twelfths is 1/2? Not that hard. 6, that's 6 twelfths, plus how many twelfths is 2/3? 8 twelfths, perfect. And how many twelfths is 1/4? 3, excellent, okay. So this will be b to the what power? You got common denominator, just add the numerators. And what does that give you? Say again? Well, no, you're subtracting the 3. 11 twelfths. And that's all you can do with it. It's b to the 11 twelfths. I don't know. I hope that's all they're going to ask you to do. Yeah, that's all they're asking you to do with it. All right. Now we've got another rule we got to apply here. And this will be negative 64 x6 y to the minus 3/2 raised to the 4/3 power. Okay. What are we going to do with that, huh? Yeah, distribute the 4/3. You're absolutely right. So it'd be minus 64 to the 4/3 power times x to the 6 to the 4/3 power times y to the minus 3/2 to the 4/3 power. Okay? You're taking 4/3 power of everything inside. Now here's the thing to watch for, folks. Should have even mentioned this before. As soon as you see a negative sign here on the base, look at your denominator of the exponent. If that's even, no real answer, okay? Because you cannot take an even root of a negative number. But if that is an odd root, no problem. The answer is going to be negative. That's all it tells you, okay? Can you get it? Okay, I can get it if you need to. All right, so what number, you tell me, what would you do next for that one? Huh? Okay, not yet. Okay, negative 64 to the what power? 1/3 power, and then raise that to the 4th power. Perfect. Okay, let's just let that rest for a moment and go to the next one. What would the next one be? I'll do the base x. I thought that might be where it was giving you problems. What do you do with the exponents? Anybody? Help me. I'm drowning up here. Bless you. Okay, no. Raising to a power, you multiply them. And what's 6 times 4/3? 3 will go into 6 twice. 2 times 4 is 8. Okay. All right. Now the y. I'll do the base part. You tell me the exponent. Anybody? Help me. Somebody. -2. Perfect. Okay. Because the 3's will divide out and 2 will go into 4 twice. Keep the minus sign. -2. All right. Let's go back to the minus 64 to the 1/3 power. Okay. What are we asking for here? What number, when you cube it, will give you -64? Those black boxes will do it for you on it. Okay, what does that give you? You did the whole thing, right? What does it give you? Negative what?
-2 to the power of 18.
Okay. Don't quite think so. Let's take it a little bit simpler than that. What number, when you cube it, will give you -64? -4. And then -4 raised to the 4th power. And that may give the same answer you said, but it's okay. So that'd be -4 to the 4th power. Okay? Everybody see that? Yay or nay? Okay? Times x to the 8th times y to the -2. Well, -4 to the 4th power, anyone want to make a guess of what that is? Say again, 256? Did you say negative? Okay, I don't think so. Anytime you raise a number to an even power, it's always going to be positive, a real number. So this will be 256, x to the 8th, y to the -2. Now, if you don't like having negative exponents, what can you do with that y? We did it earlier. Second, put it in the denominator? Yes. That would be 256 x to the 8th over y squared. Perfect. And lose the minus sign. Let's see which way the book did it. They put it in the denominator. 256 x to the 8th over y squared. All right, I've kind of run out of room for C. Can I erase the other stuff so we have more room to do C? I was getting sort of crowded with B even. So everybody got it? No? Okay. Hold on. Now, that may be the same answer you were giving me before of some number to another power. It probably was, but it wasn't easy to explain that number the way we've been doing it. Okay. I'm not saying your calculator was wrong, but it wasn't the form we've been doing. While y'all are writing, you could do -4 to the 4th power, no sweat. If that had been -4 to the 1/4 power, lots of sweat. In fact, you don't even do it because you can't get a negative number when you take the even root of it. I just snuck in something that I probably shouldn't have said yet, but I don't mind. Okay. This is a nice welcome back from Thanksgiving, isn't it? Oh, yeah. Okay. All that turkey was worth it, wasn't it? Okay. All right. Most everybody got it now? Still anybody? I see people writing, but I don't know if they're writing this or something else. Everybody got it? No? You got it? Okay. So let me erase this so we can get the C done on this page. Oh boy, what do we do with C here? Second? Okay, you can do that if you want to. Okay, let me make a suggestion here. Why don't we simplify what's inside the parentheses as much as we can, then deal with what's outside the parentheses. Does that sound like a decent plan? Because otherwise our numbers are going to get big and ugly and messy. So let's simplify what's inside first. Anything you see you can simplify. Anybody? Anybody? Or maybe there's nothing we can simplify. Say again? Oh, yeah. 8 will go into 64 how many times? 8 will go into 8 one time, 8 will go into 64. How many? Say again. Maybe this is 8 times, yes. I didn't think this would be that hard. Okay. Now, what if you had a cubed divided by a to the -9th? Let's just deal with that part next. What would that give you in reality? So the first part is going to be a 1/8, okay? And a cubed divided by a to the -9. What do you do with the exponents when you divide the same bases? Keep the base. And what? Subtract the exponent. Very good. And we have, I can't even read that anymore. Is that a 2 or a 3? 3. 3 minus a -9 is 12. Okay? So that's going to be an a to the 12th in the numerator. Ooh, the number didn't get any smaller, did it? Okay. But how about that b? Let's deal with that one now. Ooh, let me. This is getting too hard to see, so I'm going to erase that part and only deal with the b part. Okay. Now, there's 2 ways you can answer that. How would you want to do it? Anybody? Okay, b to the -6 would be perfectly fine. B to the -6. That thing we're going to raise to the 2/3 power. There are any of you that really don't like negative exponents all that much? Is there? I don't. Okay. They're fine, but I like positive. I like positive. Okay. How could you make that b have a positive exponent? Send it to the bottom, exactly. So I think I'm going to do that. So this will be a to the 12th over 8b to the 6th. That's what I'm going to raise to the 2/3 power. Okay? Y'all all okay with me now? Okay. Now let's do each one like we did before. That would be a to the 12th raised to the 2/3 power over 8 raised to the 2/3 power times b to the 6th raised to the 2/3 power. Okay? Let's start with that numerator. What would that give you? What's that? I can't hear.
I gotta write it down.
Oh, okay, good. Okay, take your time and write it down. Anyone? Say again? Yeah, just the 8. This part here. What would that give you? 8 to the 8th power. Perfect. Because the 3 will go into 12. How many times? 4. 4 times 2 is 8. So there's your numerator. Now 8 to the 2/3 power. What's that? 4? So what's that? Oh. Okay. What number, when you, okay, split this out, you want me to write it out? We can. Let's write that, like the book did, as 8 to the 1/3 power squared. Okay? Let's go on and do the b. What would the b be? The bb, that's a little round. No, never mind. Okay. 4, that's b to the 4th. Okay? Whew, all we got is that to go. Now, what number, when we raise it to the 3rd power, will give you 8? 2. Okay? And then when you take 2 and square it, that would give you 4. That's why I thought someone said 4 at the very beginning. I said, wow, and you did? And you said you didn't. Okay. Okay. So this would be a to the 8th. I can't write. Goodness gracious. It's got to be the Monday after Thanksgiving even. Okay. Okay. A to the 8th over 4b to the 4th. Now, that's about as simple as I can write the answer. And guess what? They got it right. Good for them. I'm so proud of them. Okay? All right. Any questions on that? You see what? Yes. How do you get the 4? Okay. All right. When you're doing this, okay, did you see how we went from this to that? You did. Okay. You did to the 1/3 and pulled the 2 on the outside. Okay. So here then is probably the question. How did you get a to the, what is a to the 1/3 power? Well, that's the number that when you raise it to the 3rd power, it would give you 8. What number raised to the 3rd power is 8? 2. 2 cubed is 8. So you take the 2 and square it. And that's how you get the 4. I skipped that step because I was just lazy. Okay. Very good. Any other questions? Does that make sense? Would it help me to write that stuff in there? I can. It's not hard. I was just being really lazy. It would be a to the 8th over 2 squared b 4th. And that gives you that. Okay. Good deal. Want to see how they did it? Okay. I agree that they may have messed it up and done it a little bit more complicated, but it doesn't hurt to see 2 different approaches. Okay? And you can take whichever, if you don't like the way I did it, say, oh, their way makes so much more sense. Do it, as long as all the steps are right. Okay? So let's give it a shot. And then we'll laugh at them, or we'll say, oh, we agreed. Oh, that's even better. Yuck. Okay? So let's see what we do. The first one, all we do is keep the base, add the exponents, just like we did. Use the rule for multiplying exponential expressions. And then You put them all over this common denominator just like we did. And that common denominator was 12. And 1/2 becomes 6/12. 2/3 becomes 8/12. 2 1/4 becomes negative 1/4 becomes negative 3/12. And then you add the exponents first. And that gives you b to the 11/12. They did it the right way, didn't they? Just like we did. Okay? Easiest, most straightforward way. Any questions on that? Do you see how? Okay. All right with A? All right, let's move to B. If there's any part you don't understand why they're doing, stop and ask. Okay. Here's, of course, they did a little bizarre. They start with a minus 64, and because they're psychic, they look at that, and they have a denominator here of 3, so they ask what number to the third power would be 64, and that happens to be a negative 4 to the third power. Now that, to me, is truly a backward way of doing it. But if you like it that way, you can do it that way. Okay? All right. Then they said x to the 6 stayed x to the 6. Yeah, that part stayed the same. They just started messing with this and did it that way, which to me requires more insight, and then they're not even telling you how they did it. But that's what they did. They looked and saw they had a 3 out here. So is there any number, when you raise it to the 1/3 power, will give you 64, and that happens to be a negative 4. And again, that's a totally bizarre way to do it. But it works. It's absolutely correct. Okay? Okay? Other questions? Other questions? Okay. All right. So the next step then is what we did to begin with, kind of. We raised each of these to the, okay. Other questions? Okay. All right. They raise each of these to the 4/3 power. So it would be minus 4, 3 times 4/3, x to the 6 times 4/3, y to the minus 3/2 times 4/3. That's when they multiplied in. And that's why they rewrote this as something to the third power, so the 3's would cancel out, which is sort of bizarre. So this is negative 4 to the 4th power, x, and this is 3 under that would be 2 times 4 is that x 8, y to the minus 2. Okay? So that gives us negative 4 to the 4th power, x to the 8th power, and y to the minus 2 power. Okay? Now they're going to multiply negative 4 to the 4th power, raise negative 4 to the 4th power, and do it on a calculator if you need to. But it's basically negative 4 times negative 4 is 16. That's to the 2nd power. Negative 4 times negative 4 is 16. 16 times 16 is 66. However you do it. X to the 8th, and then move the y downstairs, and it's y over y second. Okay. All right. Now, let's go to the B one. And guess what? They did do it right. Okay? They simplified the inside first. Okay? They skipped a lot of steps, but they did it. 8 will go to 64 8 times. And then a cubed over a to the minus 9 is a to the positive 12. They did that right. And then they didn't show you how, but you can do it this way too. Since this is a positive number, let's subtract this one from here, but leave it in the basement, and that's where it stays. The 8 from here and the b to the 6 there. Same thing we did, only they didn't show how they did it. Now they take each one of these and raise to the 2/3 power, just like they did before. I hope they do. Okay. And again, this takes so much more insight to say, oh, we want to write this 8 is 2 to the 3rd power, so that then that 3 will cancel into that 3 and leave it just a 2. If you see that, do it. But I don't even look at it that way, okay? Now we take each of those and they skip that step too. 12 times 2/3 is 8, so it's a to the 8th power. 3 times 2/3 is 2, so it's 2 squared. And 6 times 2/3 is 4, so it's b to the 4th. And then they square the 2 and they get a to the 8th over 4b4. Just like we did, only they did this step here, which is perfectly correct. It's just they don't tell you what the thought process of getting that. I'm trying to tell you what it is, but it's a weird thought process. All right, anyway, there's a check your understanding at the bottom of the page, 3 more, very similar to the ones we just did. Their answers are on their solutions, not just the answers, how they got it, pages S4 to S5. And then there's 6 practice problems. Please do your check yourselves. Please do the practice problems. Okay? Any questions on those? Okay. That's the end of that one. So let's move to 13.5B. Unfortunately, there is a 5C, and we're not going to get to it today. This is really unfortunate. I've been talking too much, I guess, or something. Okay, let's get the slideshow from current slide. And we're still in Module 13, which is rational exponents and radicals. And 13.5 is rational exponents and radical expressions. Okay? Which is doing one extra. Oh, that's the part. The radical expressions we haven't gotten to. That's what we're going to do in this one, which is 13.5B. Write exponential expressions as radical expressions, and radical expressions as exponential expressions. Finally, this to me is where we really need to be. Okay? Now, note that a to the 1 over n is the number whose nth power is a. Okay? We can also say that this is the nth root of a. And that's what I keep trying to say. I actually slipped out a time or two. They hadn't told us about the roots yet, but it's the number whose nth power is a. That's another way of saying the number whose nth root is a. Okay. Now, roots, remember that? That was that radical symbol. If a is a real number and n is any positive integer, then the nth root of a is a to the 1 over n. That's what I wanted to get to. Okay? And finally, we're there. In this expression, the nth root of a is the symbol, the radical symbol. That's the radical. N is called the index of the radical, and a is called the radicand, the thing that's inside the radical. Okay? So how would we write that in exponential notation? Everybody see it? How would we write that in exponential notation? 7 to the 1 over 3. Perfect. How would we write that in exponential notation? X to the 1 over 5. Perfect. Perfect. Way to go. Okay? Now, the cube root of 7 is an irrational number. That's actually the best way to write it, or like this. Either one. Perfectly fine. X, since you don't know the value, either one of these ways are fine. And many times I like this form better than that. But when you're figuring out numbers, especially if that was a perfect cube, like 27, I like this form actually better than that one, because I think of that as the cube root of 27. And that's what I've been saying, and I've tried to catch myself every time. So an exponential expression with a radical exponent can be written as a radical expression with a rational exponent. I keep getting this word crossed up. So if a to the 1 over n is a real number, in other words, if you can really do that, if a is not negative, or if a is negative, n is not even, whatever, then a to the m over n, that's a rational expression as an exponent, that's the nth root of a raised to the nth power. Okay? So your numerator stays as an exponent, your denominator becomes the index of the radical. Now let me do one more step from that. Let me write it one more way. Now maybe they're going to do it later, but I think you ought to see it right now. Okay? So look right now. Okay. Other way you can write that is the nth root of A and raise the whole thing to the nth power. So you can raise the power either inside the radical or outside the radical. And most of the time when I'm evaluating, I like to do this. Because you see, if you take this and raise it to an m power, it's going to be a bigger number, and then you have a bigger number to take the nth root of. If you can take the nth root of a smaller number, then it's easy to raise that small number to that power. That's the way I like to do it. You can either raise it to the power inside the radical or outside the radical. Most of the time I like to do it outside the radical. Okay? So, you answer this. What is 15 to the 2/3 power written as radical notation? Is what? Help me somebody. You may have said it right. Nth root of 15 squared. Okay? And you can either write the squared here or write the nth root of the third root. I said nth root. Third root of 15. You can either write the square inside here or do the square root of 15. Third root of 15 and then square it on the outside. That's an irrational number anyway, so it doesn't matter where you write it. Okay? All right, how about this one? Write that as a radical. What would that be? That's a denominator of 5. That's a speck on the board or something. Oh. Yeah, that's just part of the x. They have a little serif on the x. The 5th root of x to the 4th. That's how they're writing it. I would have said the 5th root of x and then q fourth that. Okay, write that as an rational exponent. What would that be? 2 to the 3/5. Perfect. And this one would be 5 over 6. Perfect. Y'all are good. Really, really good. And unfortunately, are we out of time? Oh my goodness, how did that happen so quickly? Okay. All right. We will start next time on this focus at the top of this page. So, there we go. Good deal. Thank you so much. All right. All right. Any questions? Good deal. Thank you. What's that? I'm going to be really mad at you. What?
I lost the quiz.
Lost the quiz. Okay, how many points does that take off? 455, I think it was. Okay. I'm not mad at all. I don't know. No problem. Well, let's see. There have been a few people that haven't shown up, so I'm guessing I might have an extra 1 or 2. So let's see if I can find them. Oh, did I tell you how much this is going to cost, though? That may be what I left. No. Okay. There you go. Okay. Hey. Yeah. What's that?
Take the test
Wednesday after class? Okay.
Can I take an class?
Huh?
Can I take an class?
You know, I think you've asked me that before, and I said, well, I guess I'll have to let you, and then you never did come and do it, did you?
Yeah, I was late.
Okay.
I slept in.
All right, good deal. Thank you. If there's no other time you can do it then, but you'll be missing what's in class.
I never got the course key for the book, so I can't do the check your understanding and whatnot.
Okay, you never got one?
The course key for the book.
Oh, you did?
Yeah, I'm really, really late.
Okay, there it is. I gave it
Oh,
to you.
right here?
Yeah. Well, it's Lawson.al
Okay.
and then 2874 8031. And there has to be that space in between.
Did you get the quizzes?
What's that?
Did you get the quizzes that
Yeah.
were turned in before Thanksgiving?
Okay.
Right.
Let's see this last quiz.
Mm-hmm.
Okay. Sorry about this.
Thank you.
All right.
Who's the last quiz that we did at
What's that?
I don't
You-
think I got this book.
You don't have it?
I don't think I did. I
Okay.
can't remember.
It looks like this. It's all radicals.
Yeah.
Okay. Yes.
Ariana Harris.
What's that?
I want to see my quiz.
Oh, okay.
Yeah,
That's it.
Ariana Harris.
Yeah, I think I know who you are. And
What
you,
all does our paper have to include again?
whatever you want to include with it, it can be about a person, an event, so whatever you choose to write on, just write it,
What we take
But
the
it just
quiz?
got to be about anything math related.
anything math related, pretty much. Yeah.
Does it have to be math 100 related or just like math?
Pretty much anything.
Oh, okay.
Pretty much anything.
Yeah.
So this is going to be on our quiz.
On the test, yes.
When we
The first,
take the test.
when we finish that last section, which will probably be
So then
next time
that's
we
going to be
finish.
on there too.
Yeah, this stuff will be on there too. This will be almost sort of the first half, and the second half, probably a little more than the second half, will be what we covered since then.
Okay.
Okay? I wish I could give it back to you, but I don't have them all in yet.
You say you got to be double spaced? Or,
Oh yeah, double space for sure, and word processed. And you have
one
take-
page.
1 to 2 pages. It has to be more than one. What's that? And you need to include a page from your source. Huh?
I said, when the test?
I can't hear you.
I'm sorry. When the test?
When is the test? Probably next Monday. I hate it's that close to
So
finals.
we're going to get another quiz.
No, not on this stuff. No.
So this is going to be on the test.
Yeah. This is on the test. The first half of it is like the quiz stuff. Not quite half. A little less than half. Second, a little bit more than half will be the stuff we've been doing since then.
Okay.
Okay.
Said we had to put the source on.
What's that?
Say something about the source or something like that.
Okay, you have to have at least one outside source. Okay, and you need to include a page from that source. That was all in the instructions. All right. We'll see you next time. Okay.